Welcome to my channel. In this video, we will discuss how to resolve a given force into rectangular components. Let us consider a force F. While resolving the components, we need to consider the following points. Number 1. The component should be drawn parallel to the axis under consideration. Here, Fx is called the horizontal component or the x component, drawn parallel to the x-axis. Fy is called the vertical component or the y component, drawn parallel to the y-axis. Number 2. Rectangular components will be at right angles to each other. Number 3. The resolution should comply with the parallelogram law of forces. That is, if we draw two lines parallel to the components, it should form a square or a rectangle, and the resultant force should be passing through the diagonal. Now let us discuss how not to resolve a force. Consider an xy axis. Let there be a force F in the first quadrant. Let's indicate the directions of the components now. Fx parallel to x-axis and Fy parallel to y-axis this way. Are these directions of the components taken right or wrong? Well, if you observe here that the resultant of the components is obtained in the fourth quadrant. Therefore, the directions taken are wrong. Now let's change the direction of the vertical component Fy. In this direction, upwards. Now if you observe, the resolution of the force is conforming to the parallelogram law. Hence, the direction of the components now correct. Now let's indicate the directions of the forces in different quadrants of xy axis. Here is the first force F in the first quadrant. Its components are Fx and Fy. Taking the second force P in the second quadrant. Its components are Px and Py. Taking a third force Q in fourth quadrant. Components are Qx and Qy. Taking the last force T in third quadrant. Its components are Px and Ty, all conforming with the parallelogram law. Observe here that the components directed towards positive axis are taken positive, and those in negative direction are taken negative for their magnitudes. Now let's find out the magnitudes of the components and other elements. Let's say that the magnitude of the force P is given. Its components will be Px and Py. Let theta be the given angle between force P and its horizontal component Px. If we take the free vector of Py on this side, we get a vector triangle where P is the hypotenuse, Px is the adjacent side, Py is the opposite side. From this triangle, the horizontal component or the x component will be Px is equal to minus P cos theta. The negative sign is because it is in the negative direction of x-axis. The vertical component or y component is Py is equal to plus P sin theta. The positive sign is because it is in the positive direction of y-axis. When the magnitudes of the components are given, we can find the resultant force P is equal to root of Px square plus Py square. Again from the triangle, tan theta will be equal to opposite side by adjacent side. It is equal to mod Py by Px, or theta is equal to tan inverse mod Py by Px. Here we are considering only positive values of the magnitudes of the components. Now let's find out the magnitudes of the components and other elements when the slope of the force P is given instead of angle theta. Let this be the slope of force P with x horizontal, y vertical and d the hypotenuse. Taking the free vector of Py on this side, it forms a triangle similar to the slope triangle. Here we can say that Px and Py are the force components of P, whereas x and y are the distance components of D, which will be similar in proportion, and hence we can equate the ratios as minus Px by x equal to plus Py by y equal to P divided by D. From this equation, we can find anything that is required to find. From the slope triangle, we get distance component x is equal to d cos theta and distance component y is equal to d sin theta, and length of the hypotenuse d equal to root of x square plus y square. From the slope triangle, we can also find the angle theta by taking tan theta equal to y by x or theta is equal to tan inverse y by x. Finally, let us understand the convention of measuring an angle theta or the orientation of a force. One of the methods is to measure the angle with respect to positive x-axis, and we get the angle as positive or negative based on clockwise or anti-clockwise measurement. The other method is more convenient, where the angle between any given force is measured with respect to positive or negative x-axis based on the quadrant in which the force is situated. Hence, the angle theta that we obtain here is always positive. There is no negative convention. For this, we always consider the positive magnitudes of the components while calculating the angle theta from this equation. That's all in this video. Thanks for watching. Have a nice day.